Alright, so now we want to show that the following statement is true for all n and n. The sum of 1 plus 4 plus 7 plus ... times 3n minus 2 will equal 1/2 n times 3n minus 1. And just to keep in mind that when we're doing these, like when we say n is 5, that means you're taking the first term plus the second term of the sequence plus the third term of the sequence plus the fourth term of the sequence plus that fifth term of the sequence. And so you're adding up all those terms of the sequence. So you can picture like this is your sequence, the 3n minus 2, and when n is 5, you're going to add up those 5 terms. Alright, so another thing to notice is that in just the setup of the problem is I have a couple of fill in the blanks. I want you to start just knowing what to write. The more problems we go through, the more you'll just be including that writing. So, and this is like the structure and the format that you want to do for all the induction problems. So think about this as like your recipe and just following this recipe. So the first condition is to show that the statement is true for n equals 1. And so that means that, well, when n is 1, 3 times 1 minus 2 is that 1. So essentially, does 1 equal 1/2 times 1 times 3 times 1 minus 1? 3 minus 1 is 2, and then 2 times 1/2 is 1. So this is true. And if we just wanted to get some warm fuzzy feelings that this is a true statement, when n is 2, you're adding up the 4 and the 1, and that should equal 1/2 times 2 times 3 times 2 minus 1, and so we should get 5 equals 5. The 2's cancel, and then 6 minus 1 is 5, so that works. If we try n equals 3, we'll have 1 plus 4 plus 7, and that's supposed to equal 1/2 times 3 times 3 minus 3 times 3 minus 1. So we'll get 12 on the left. On the right, we're getting 9 minus 1 is 8. 8 divided by 2 is 4, and 4 times 3 is 12. So I'm getting pretty convinced that for any value of n, this is going to be a true statement that we can determine the sum. Alright, so for condition 2 is that we want to suppose the statement holds true for some n equals k. And so this means 1 plus 4 plus 7 plus ... plus 3k minus 2 is equal to 1/2 k times 3k minus 1. So we are assuming that this is true. And what we want to do is show that the statement is going to hold true for n equals k plus 1. So we'll assume it's going to work for the next term. And so we can express this by adding the next term to the sum, and we're going to show that. So what happens when we plug in k plus 1 to the right side? We should expect it to look like 1/2 k plus 1 times 3 times k plus 1 minus 1. So when we add the k plus 1 term to that sum, we should show that it is equal to this in the end. So that is, we want to show 1 plus 4 plus 7 plus ... plus our 3k minus 2, right? So that's the first k terms. Now we're adding the k plus 1th term, so this will be 3 times k minus 1 minus 2, k plus 1, the k plus 1 term, minus 2 equaling the sum that what we're trying to show. So let's go ahead and clean up this part of the parentheses. We'll get 3k plus 3 and then minus 1. So we'll have 1/2 k plus 1 and then 3k plus 2. And at this point, we don't want to like move the stuff on the left to the right or move the stuff on the right to the left. We literally want to show that the left side is the right side. So you can, if you want, manipulate just the right side to get it in a more likable form, but we definitely want to play with the left side right now. And so the first thing that I see is that I have the sum of those first k terms. So this is by that induction hypothesis. By induction hypothesis, since this is what we're assuming is true, we know that it's going to end up equaling 1/2 k times 3k minus 1 plus this k plus 1 term, so it's going to simplify to 3k plus 3 minus 2, so plus 1. And we want to show that whatever we can still do on this left, it's going to be this thing on the right. And so I can distribute the 1/2 k I can distribute the 1/2 k. This is going to leave me with 3/2 k squared minus 1/2 k plus 3k plus 1. And then when we add this, we'll end up with 3/2 k squared, 2.5, so 5/2 k plus 1. And then we're still supposed to show that it's this right side. And what I'm seeing this left side is, I'm kind of running out of space, is I still want to factor out that 1/2. So technically I kind of jumped the gun distributing it. So take out the 1/2. This would leave me with 3k squared plus 5k plus 2. And then this in fact does factor to 1/2 times 3k plus 2 and then k plus 1. So I'm running out of space, but you can see that these are now the same. And so you can conclude that since conditions 1 and 2 are satisfied, the statement is true for all numbers by principle of mathematical induction, or just MI. Alright, so I hope you found this helpful, and we'll look at a couple more problems.